Hello dear viewers, welcome. This is Excel Science Tuition and today we are going to study about separating mixtures. In your class, you are a mixture of many people from different backgrounds and with different behaviors, but I'd like you to embrace those that can help you and refuse to be generalized with those that cannot help you. Avoid bad company because even in the scripture, it is said that bad company corrupts good moral. I'd like you to separate yourselves from the rest and remain with the ones that are focused. Don't lose your focus in academics. Just move on and you'll make it at the end of the course. Now let's begin our topic today. It's about separating mixtures and this is our first lesson. Now we're going to start by studying simple classification of substances, and first we'll begin by defining what is matter, and we will say that matter is anything that has mass and occupies space. Matter can be classified into pure or impure substances. Impure substances, we can also refer to them as mixtures. A pure substance is one which contains only one substance, while an impure substance is one which contains two or more substances. A mixture is a combination of two or more pure substances which can be separated by physical means. So you will realize that a mixture can be separated by physical means, while a compound is a pure substance that is combined of two or more pure substances that are not physically that cannot be physically separated. So a compound can only be separated chemically. So we have said that under matter we have solids, liquids and gases. Those are the three states of matter. So under matter we have mixtures and pure substances. Pure substances, we have elements. An element is a pure substance that cannot be split into simpler forms. So that is under pure substances. While in mixtures, we have homogeneous mixture and heterogeneous mixture. A homogeneous mixture is a uniform mixture, while a heterogeneous mixture is an ununiform mixture. So you'll realize that now we have studied about matter, pure substances, impure substances or mixtures, and now we're going to study how to separate those substances, because we have said that mixtures, we can separate them physically. So now we have the first method of separation, that is called sorting or picking. This involves physically picking one pure substance from a mixture with another or other. For example, sorting maize from maize beans mixture. This is the same as just putting the maize aside and putting the beans aside. That is also sorting. But picking, you just have to pick. Let's say you are picking maize alone, because it has a texture that can be picked. Its size is large. We also have another method that is called decantation. Decantation is used to separate heterogeneous mixtures. This involves pouring out a liquid from a solid that has settled or that has sunk in it. For example, decanting water from sand. You'll realize that when you put sand inside water, the sand will sink. And when the sand has sunk, you can remove the water, you can pour out the water carefully and remain with the sand. We also have another method of separating mixture that we call filtration. Filtration involves sieving or passing particles of a mixture through a filter. In the lab we use a filter paper, but you can also use another filter that contains small holes that allow smaller particles to pass through but do not allow bigger ones. So the substance that has small particles will pass and will go downwards, while the other will remain on top. The one that has remained on top, we call it filtrate, while the one that is in the bottom that has passed through the filter, we call it distillate. We also have another method of separating mixture that we call skimming. Skimming involves scooping floating particles. For example, we can skim cream from milk because cream floats on milk. So we can scoop it, or we can just remove it by using maybe a spatula or even a normal spoon to remove it. We can also skim foam from water because it floats on top. The other method of separation is called distillation. Distillation is an improved evaporation where both the solute and the solvent in the solution are separated. So another method of separation is evaporation, and then we have an improved evaporation method that we call distillation. Why do we call it improved evaporation? Because it has condensation. Because distillation, therefore, is the process of separating a solution into its constituent solid solute and the solvent. It involves heating up the solution to evaporate the solvent out. The solvent vapor is then condensed back. So one of the substances is allowed to pass, while the other is allowed to condense back to the conical flask. So we have two methods of distillation. We have the simple distillation and we have the fractional distillation. So we use fractional distillation when we want to separate substances. We use fractional distillation when we want to separate substances that have close but different boiling points. For example, water and ethanol. The boiling point of water is 78. The boiling point of ethanol is 78 degrees, while the boiling point of water is 100 degrees. So you can see there is a small difference between 78 and 100. So that is why we can separate the substances by use of fractional distillation. So this is the setup for fractional distillation. The first point, we have the thermometer inserted here in a tight cork. So this is the thermometer. What is the function of the thermometer? The thermometer is used to measure temperature. Remember, we learned about apparatus for measuring temperature, and we said there are three types of thermometers. We have the clinical thermometer, we have the liquid in glass thermometer, and we have 6 maximum and minimum thermometer. Now this thermometer that we are going to use here is the liquid in glass thermometer, or just the normal thermometer that has a scale from 0 to 100, or from -10 to 110. Why? Because the boiling point of water is 100, while the boiling point of ethanol is 78 degrees. So the scale will be suitable. Why not use a clinical thermometer? A clinical thermometer has a scale of from 0 to 45, because the normal temperature of a human being is 37. So that is why we cannot use it here. So this is our thermometer. We'll be reading the temperature at which the ethanol will start entering into this Liebig condenser. So we have this column here, this one is what we call the fractionating column. This one, the outer column, this one is what we call the fractionating column. Fractionating column allows the evaporated ethanol to pass and go to the Liebig condenser, while water to go back to the conical flask. We also have what we call glass beads. The glass beads are used to provide a surface area, a large surface area for condensation. Because they are circular, then at this point we'll have a large surface area for condensation or cooling. Then we have this one. This one is just the normal conical flask that is used to keep the mixture. Our mixture here is water and ethanol. Then we have the source of heat. We said that one of the source of heat that we use in the lab is a Bunsen burner. And we said that a Bunsen burner can produce a luminous or a non-luminous flame depending on how we adjust the collar. So here we let the air to mix with the laboratory gas, and that's we will have a non-luminous flame which will heat the mixture to its boiling point. Then from there, after it has evaporated and ethanol has come to this place, we have cold water entering through here and warm water getting out of here. The reason why the cold water is allowed to enter from the bottom is so that the force of gravity will not interfere with the process, because if water was entering from this point, it will be getting out faster without performing its role. So this is what we call the Liebig condenser, because it contains water, and this narrow tube here, this is where the ethanol steam condenses to liquid, and then it falls here inside the beaker. While the water, since its boiling point has not been reached, the water gets back to the conical flask. So in this, we will have separated water will remain here, and then we'll have ethanol here. So if we are told to name this one is what we call the distillate, or we can call it ethanol, because ethanol will be the first one to be emitted, or it will be the first one to come out, because it has a low boiling point of 78 degrees Celsius. What is the purpose of water? Water is meant to cool to condense the steam back to liquid. So this one is just like a stand. This is a stand, a tripod stand that we use to make the conical flask to be stable for heating. We also use a wire gauge here, so that we can evenly distribute the heat, so that every part of this container will get heat and this mixture will get to its boiling point faster. So this is the setup of a fractional distillation. We have said that we use fractional distillation when we want to separate substances that have close but different boiling points. So now I'd like us to look at the industrial application of fractional distillation. First, where do we use fractional distillation in large scale? In large scale, we use fractional distillation in fractional distillation of crude oil in an oil refinery. Remember, when we were introducing this topic, we said that we're going to learn about separation of mixtures. When we talk about crude oil is made up of very many substances. It is made up of petrol, it is made up of naphtha, it is made up of kerosene, it is made up of diesel, it is made up of bitumen. Bitumen is the one that is used for tarmacking roads. So that is a mixture. And then, if you can note, these substances, all of these ones, have close but different boiling points. Again, you will note that those substances have different densities. So we can separate them by use of fractional distillation. When we heat the mixture, the first one to be emitted will be the one that has low boiling point. Then you continue like that until we get the final substance that has the highest boiling point. So some of the substances that we get from crude oil are petrol. Petrol, we use it in driving light motor vehicles such as saloon cars. Naphtha, we use it for making chemicals. Kerosene, we use it as jet fuel and domestic lighting. Then we have diesel. Diesel, we use it for driving heavy motor vehicles such as lorries and buses. We also have fuel oil. Fuel oil, we use it in driving factory machines and ships. We also have lubricating oil that we apply in machines to reduce friction. And then lastly, we have what we call bitumen that we use for tarmacking roads. So those are some of the products that we get from crude oil. So one of the applications of fractional distillation in large scale is the fractional distillation of crude oil. Secondly, we have fractional distillation of liquefied air. In the chapter of air and combustion, you learned that air is made up of dust particles, carbon dioxide, nitrogen, water vapor, oxygen, and some little hydrogen and argon. So, in fractional distillation of air, we are targeting some gases. For example, we are targeting 3 gases: nitrogen, oxygen, carbon dioxide, and argon. Why those gases? Because they are very useful gases. They are very useful. And we obtain them by fractional distillation of liquefied air. When we talk about liquefied air, it is air that has been compressed to -200 degrees Celsius to form a liquid. And this liquid is now taken through fractional distillation so that when the boiling point of each of the gases is reached, the gas is separated. So the products of this fractional distillation, we have oxygen, nitrogen, and argon. So those are the 3 gases that are emitted because they are useful. Oxygen is used in hospitals to support those with breathing challenges. It is used by mountain climbers. It is used by deep sea divers so that they can support their life. Nitrogen is used in the manufacture of fertilizers. It is used in the manufacture of ammonia. So you can see all those gases have a variety of uses. Then argon. Argon is used in bulbs, in light bulbs. So we obtain those gases from air because they are useful. So the first application, you have said, it is fractional distillation of crude oil. The second application is fractional distillation of air, liquefied air. The third one is in recycling used oil. Used oil is recycled so that it can do the same function that it was doing before it started getting used up, or before it changed its color to black. Good oil is brown in color, but when it is used, it becomes black. So that black oil can be recycled as a means of saving costs. So those are some of the applications of fractional distillation. And thank you for coming with me to the end of this lesson. I appreciate you so much. Continue working hard and are going to succeed. If you've not subscribed, please press the subscription button for more of this content. Thank you.